Okay, today we're going to work on lesson 7.3, which is the third and final technique we have for solving a system of equations. This is going to be by using elimination. Typically, this is one of the methods that people seem to gravitate towards the most. It's pretty straightforward, it's pretty simple. Like I said, given a choice, a lot of people tend to go to this one. All right, so let's take a look at how we do this. All right, when we're solving a system of equations using this elimination technique, one thing that we have to be certain of, first of all, is that when we have the problem set up, we have to make sure that everything is aligned correctly. That's step one. Write the system so the terms are aligned. And what I mean is when we stack these two equations, we want the x variables in the same line. We want the y variables in the same line. The equal sign needs to be in the same position. And then the number on the right side of the equal sign, those where those need to be. All right, that has to be done first. And typically in the ones that you're going to get on Alex, that you don't have to deal with that. But that is something that could come into play given a different variety of questions. All right, in step two, this is where the elimination takes place. The first type of questions you're going to get are going to allow you to just add or subtract the two equations together. And by doing that, you'll eliminate one of the variables. What I mean by eliminate is when you add or subtract the equations, one of them will go to a zero. You'll get like a 2x plus a negative 2x, that's zero. Or you'll have a situation where it's a 3y minus 3y, that's zero. So you're going to eliminate one of the variables by making it a zero, therefore leaving only one variable in the equation, which you then solve for. When you're done with step two, you'll know one of the two values for your ordered pair answer, either the x or the y value. And then in step three, you'll take that answer and plug it back into one of your original equations, and that will tell you what the other value is, and then you're ready. You're ready to write your ordered pair. You have your solution. Okay. So just kind of going through this several examples here and showing you what this looks like. So here's our first system. And again, I'll always number it. Here's equation one, here's equation two. All right. When you look at the system, you can see that the x variables are stacked, the y variables are stacked, and we have the equal sign, then we have numbers. So it's set up correctly. And when I look at my terms here, I have a negative 3x in the first equation and a positive 3x in the second. Those are opposites of each other. So if I add these two together, if I just add the system, when I say add, I mean add straight down. Okay. If I add these together, we will eliminate the x variable. Okay. When I add down, we're going to go negative 3x plus positive 3x. That's zero. 0x, which is zero. All right. And then add here 4y plus negative 6y, negative 2y, 12 plus negative 18, negative 6. So in this first step, we eliminated the x's. I have the y variable remaining. Divide each side by a 2. Y is equal to 3. Okay. So now I know what the y value is for my ordered pair answer. It's 3. I go back up here, pick either equation. Okay, I picked equation 1. I substituted 3 in place of y of equation 1. Solve it. Negative 3x plus 12 equals 12. Subtract 12 from both sides, you get 0. Divide 0 by negative 3, you get 0. So the ordered pair is 0, 3. If you want to see if you're right, put 0 in place of x, 3 in place of y, and you're going to see that it makes both the equations true. What that means is graphically, guys, if you were to solve this for y, to find the slope and the y-intercept and graph it, solve this equation for y, find the slope and y-intercept and graph it, these two graphs would cross at the point 0, 3. Okay? All right, look at another one here. Whoops, let me back it up here. Here's equation 1, here's equation 2. All right, like I said, the first few questions tonight are going to allow you to just be able to add or subtract and get your solution. So now when I look at this, I see in equation 1, I got a positive 4x term. In equation 2, I have a positive 4x term. All right, the y terms are different and everything's lined up. So here's the thing. I don't want to add these together this time because 4x plus 4x is 8x. I'm trying to eliminate this. So in this case, we're going to subtract the equations. 4x minus 4x is 0. 2y minus negative 3y is actually 2y plus 3y. That's 5y. 28 minus 18 is 10. Okay, so we've eliminated the x terms. I got 5y equals 10. Divide both sides by 5, y is 2. and then take one of the two equations, doesn't matter which, substitute my 2 in place of the y. Looks like I took equation 1, put 2 in here, solve it, subtract a 4, divide by a 4, x is 6, so the solution is 6, 2. The one ordered pair that makes both of these equations true is the ordered pair 6, 2. X is 6, y is 2. Okay, another one. Okay, here's my equation 1, here's equation 2. Okay, I look at the x terms, one's 9x, the other is 1x. The y terms, negative 2y, negative 2y equals the numbers. Okay, so if I'm going to eliminate a variable term, this time I'm going to eliminate the y's. Now, notice that they're both negative. Okay, if they're the same, negative 2, you have to subtract. Okay, so in this case, we're still going to subtract. All right, so 9x minus 1x is 8x. Negative 2 minus negative 2y becomes negative 2y plus positive 2y. That's 0. So you still got to subtract here to get your 0. And then 30 minus 14 is 16. Okay, so now I've got the x term. I'm going to divide each side by 8. X is 2. So now I know the value of x is 2. I come over here. I take equation 2 and put 2 in place of x. Do the substitution. Now solve for y. I got to subtract 2 from both sides. Divide each side by negative 2. Don't miss that negative sign. Y is negative 6. Answer is 2, negative 6. Okay. So there's my solution to that one. Okay. One last time here. Looking at your equations, the thing is, make sure we're all lined up first. X terms, Y terms, equals, numbers. We're good. Okay. Look at our X terms here. One's positive 3x, one's negative 3x. So I know I'm going to add these two together to eliminate the x term. What happens here, though, is notice that the y term, this is really a negative 5y and a positive 5y. So when I add together here, I actually wind up with elimination of both variables. 3x plus negative 3x, 0. Negative 5y plus positive 5y, 0. 1 plus 9, 10. Now, just like when we solve equations, if our variable terms all cancel out, then I got to look at what remains. Is this true or false? Does 0 equal 10? No. Since 0 does not equal 10, it's a false statement. That means there's no solution to the problem. Graphically, what does that mean? The lines are parallel. Okay, there's no solution. Now, if we do this and, I get 0 equals 0, true statement, now it's an infinite number of solutions. In other words, they're the same line. So those can still pop up even when doing the elimination technique. Now, the next thought here is what happens if we're given a system and we don't have numbers, we don't have x's or y's that are the same or opposites? Well, what we do then is we create them. All right. So we're gonna manipulate the equation. We're gonna multiply one of the equations by a number, positive or negative number, so that I can create opposites. Okay, we're going to manipulate that equation, one of the equations, to create opposites, and then I pick up and do what I just got done doing. Once I create opposites in step 1, we can add the equations together or subtract. I'm always going to add because I'm going to create opposites, and we'll eliminate a variable, define the value of that variable, and then plug it back in the third step. Same as what we did before, substitute that answer back into either equation and find our other ordered pair value. Okay, so this is kind of the next step in this process. So here we go, equation 1, equation 2. All right, so equation 1, I got 2x, 3x. Those aren't the same, nor are they opposites of each other. I got 1y and 2y. They're not the same or opposites. Okay, so I got to do something here to create opposites. What I like to do is what I just said, create opposites. So what I'm going to do is I'm going to take equation 1 and multiply everything by negative 2. As long as I multiply both sides by negative 2, I create an equivalent equation. All right. But what it will do is by multiplying by negative 2 is it will give me negative 2y to match the positive 2y I have in my other equation. All right. Distribute the negative 2 through. Negative 4x minus 2y equals negative 46. Keep this equation the same. We'll just bring it over. And now when I look at my equations, I see right here I got negative 2y, positive 2y. That's by design. Okay, so now I'm going to add them together again. That's why I'd like to create opposites, because I'd rather add than subtract so I don't miss signs. Okay, so we're going to add down negative 4x plus 3x, negative 1x, negative 2y plus positive 2y, 0. Negative 46 plus 37, negative 9. At this point, I got to get my coefficient of x to be a positive 1. You're either dividing each side by negative 1, or you can multiply both sides by negative 1. X equals 9. Then go up here, pick an equation. I'll probably pick equation 1 because it'll be easier to solve for y, since y's got a coefficient of 1 here. I'm going to substitute my 9 in place of x. Solve it. Subtract 18. Y is 5. So the answer is 9, 5. All right. So this little process here of multiplying an equation by a number allows us to create opposites so that we can eliminate. Okay. We'll do another one. Okay, equation 1, equation 2 here. Again, my x terms, not the same number, nor are they opposites of each other. Y terms, not the same or opposites. So I got to create it. All right, so what I see is I'm going to take equation 1 and I'm going to eliminate the x's. I'm going to multiply everything by negative 3, because I know negative 3 times x is negative 3x. Now I got opposites. Okay. But I got to multiply everything by negative 3. So distribute that negative 3 through. Negative 3x minus 21y equals negative 36. We're going to leave this equation as is because it gives me the opposites for my x's. Again, I want opposites so I can add. I like to add rather than subtract. So negative 3x plus positive 3x is 0. Negative 21y plus negative 5y. That's negative 26y. And then negative 36 plus 10 is negative 26. Okay, divide each side by negative 26. Y is 1. Pick either equation. I took equation 1. I'm going to substitute 1 in place of y, and now I can find x. Okay, 7 minus 7 from each side. X is 5. There's my ordered pair, 5, 1. Okay. All right, so that's what you're going to work on tonight. You're going to work on using elimination to solve a system of equations. Okay, your first several are going to be, they'll give you opposites or the same so you can add or subtract. And then the second group of questions, you're going to have to multiply one of the equations by a value to create opposites so that you can add and eliminate and then solve. Okay? All right, make sure you are writing out work, guys. Work will be collected for this, so write your work out so I can see it. All right, have at it.